Okay, so all the idea now is to show two things for positive definite matrices. We want to show that if I have a positive definite quadratic form, namely that is represented by a positive definite matrix, then the diagonal elements, the diagonal coefficients that are on the diagonal of the matrix, if you want, must be positive numbers. But the inverse is not correct, namely, if all the diagonal elements are positive, it doesn't mean that the matrix must be positive definite or the quadratic form must be positive definite. Okay, so this is the general form for quadratic form, and we want to start by showing that if this quadratic form is positive definite, if the matrix is positive definite, then all the diagonal elements, all the AII if you want, are positive. So this is the goal now. Let's see. So assume that we have a positive definite quadratic form. Let's call it Qx, namely for every x which is non-zero, the Qx is greater than 0, namely positive. Now we will use the standard basis, the standard basis E1, 1 here, and everything else 0, E2 is 1 over here in the middle, and everything else is 0, and etc., etc. And we will show that it gives us a positive number for each one of them, and it represents AII, namely diagonal elements. So if I take the quadratic form with the standard basis, what I get is that when I apply the standard base, one of them to here, what I get is AII for EI. EI is 1 in the position I in the vector, and everything else is 0. So AII is what I get when I apply QEI, and if the quadratic form is positive definite, it must be that it is positive, namely more than 0, as it is not a 0 vector. Therefore, every AII is positive. These are all the diagonal elements. Therefore, we proved that all the diagonal elements of a positive definite matrix of positive definite quadratic form are positive. Now let's go to the next step, which means that the converse is not correct. Namely, if all the diagonal elements of a symmetric matrix or a quadratic form are positive, it's not enough for the quadratic form or the matrix to be positive definite. It may be, it may be not, but it's not enough. It's not sufficient condition. So let's look on a non-positive definite quadratic form. We'll take x1 squared plus 4x1 x2 plus x2 squared. This is the representing matrix of this quadratic form. You understand this is coefficient 1, so here 1, 4 here, so 2 and 2 here, and 1 here, so 1 here. Now you can see that the diagonal elements are positive, right? A11 is 1, A22 is 2, A is 1. Now take, for example, this vector. This vector, when you apply it to the quadratic form, what you will get is minus 2. Now, by definition, for a positive definite quadratic form or as a positive definite matrix, every vector which is not the 0 vector that you apply to the quadratic form should give you a positive number if it's a positive definite matrix. But here, we used a non-zero vector and we got a negative number. Therefore, this matrix is not positive definite. This quadratic form is not positive definite because when you apply something, a vector which is not a 0 vector to the quadratic form, you got something that is negative and not positive. So it's not a positive definite matrix. You can also use the Sylvester criteria, which said that you can take the minors and check their sign, the determinant of the minors, their sign, and for a positive definite matrix, they all need to be positive. So when you take and do that, for the first minor you get 1, which is positive, great, but for the second minor, which is all the determinant of the matrix, in this case, you get minus 3, which is a negative number. Therefore, D2 is negative, and not all the minors are positive. It means that the matrix is not positive definite, and the quadratic form is not positive definite in this case. Okay, so that's it. This was about the relation between the diagonal elements and the positive definite matrix. If it's positive definite, yes, the diagonal elements will be positive. But in general, if the diagonals are positive for quadratic form, it doesn't mean that it must be a positive definite matrix. It may be, but it also may not be. Thank you very much. Thank for Gemini for writing this down. If there are any mistakes or correction, please tell me. Thank you for watching. Thank you all, and that's it for now.